go ahead. This is example 2. Okay, in example 2, we consider multi-story frame structure. Okay, for multi-story frame structure, in this case, we also have some connections which connect more than equal to more than 2 members. Okay, more than 2 members. So we have many possible plus hinge locations. For example, for joint B, we have 3 sections which are possible plus hinges. Okay, and again for joint G, we have 3 possible locations. Okay, so again, you just need to analyze some elementary maxim and some combined maxims. Okay, so this is the first one. This is a beam maxim, but just for the top story. Okay, we have 2 stories. So for top story, we have a collapse. Okay, and in this case, you have to take the plus moment for all 3 plus hinges equal to the plus moment for the top beam. Okay, because it is you have to take for the internal plus hinge, you have to take a moment for equal to the plus moment for the top beam. But for the 2 plus hinge at the 2 ends, you have to take the plus moment equal to the lesser value between the column and the top beam. Okay, because this joint just connects 2 members, so you have to select the lesser value. Okay, you have to select the lesser value. So this is the first case, and in the second case we have a bottom. Okay, correct maxim. It is different. Okay, I want to show you it is different from the top beam maxim. Okay, in the top beam maxim, for the 2 ends, we select the plus moment equal to the lesser value. But for the bottom beam maxim, because the 2 segments, the 2 columns at the first and the second story keep radial connection. Okay, keep a radial connection. So the plus moment is just at the first story beam. So you have to take the plus moment equal to the plus moment for the beam, not equal to the lesser value between the beam and the column. So please understand the difference for the beam maxim at the first story and at the top story, because at the top story, the connection just connects 2 members, but at the first story, each connection connects 3 members. Okay, so you have a different choice. Okay, so this is a beam maxim, and also we have a top story sway. Top story sway for the 2 plus hinge at the top story, the plus moment is equal to the lesser value. Okay, but for the plus hinge at the bottom, okay, at the bottom of the top story, you have to take the plus moment equal to the plus moment of the 2 columns. Okay, because here we assume the connection between the column at the first story and the beam radial connection. Okay, so here you have to take the value equal to the plus moment for the column at the top floor. Okay, so please understand the difference. But in this case, of course, they are the same, because for different members, okay, the plus moment is a constant value. But when you have a different plus moment for different members, please understand the difference. Okay, understand difference. For two member connection, okay, you just need to select the lesser value. But for 3 member connection, okay, you should determine the plus moment equal to the plus moment for the member, okay, with corresponding plus hinge. Okay, because now the plus hinge can be located at different members, at different connecting members. Okay, And this is another bottom storage way. Okay, if I put this question in the final examination, definitely some students will make mistake. Okay, in this case, okay, we only have plus hinge, 4 plus hinge at the 4th story. Okay, so you know how to determine the plus moment for the 4 plus hinges. Okay, actually the plus moment for all 4 plus hinges equal to the plus moment for the plus moment of the two columns at the 4th story. So it's not big problem. Okay, because if you don't need to mind how about the plus moment for the beam, and you don't need to compare the plus moment between the beam and the column. You just need to take the plus moment for all 4 plus hinges equal to the plus moment for the bottom columns. That's all. Okay. The problem is some students make mistake here because in this case we don't have any contribution from the top frame. Okay, but no any contribution from the top frame means no contribution to the internal energy. Okay, the contribution to the external energy is still there. Okay, because there is a rigid movement for the top frame. Okay, for the 2nd story there is a rigid movement. So here we still have a horizontal diffraction. So the force applied at the top frame still has contribution to the external energy, not just this one. Okay, some students ignore the contribution from the force applied at the top story. Okay, this force still has contribution to the external energy because the diffraction here is same as the diffraction at the 1st floor. Okay, at the 1st floor. So please understand, here we have 2 terms. Not just one term, not just one term. Okay, you just need to keep in mind this point. Okay, this point. Okay, and here is a combined case 1. Okay, in this combined case, okay, it's 2 segments for each beam. Okay, keep continuous. Okay, keep continuous. So and also the 2 beams. Okay, keep horizontal. So for the plus hinge at the base, okay, the plus moment equal to the moment, the plus moment is equal to the plus moment for the 2 columns. And for the plus hinge here and here, you have to take the plus moment equal to the plus moment for the beam, at the 4th story. Okay, and for the 2 plus hinge at the top of the structure, you have to take the lesser value. Okay, so for 3 levels, they have a different plus moment selection criteria. Okay, selection criteria. So here we have to take the lesser value. Here you just need to take a value about the beam. Here we have to take the moment about the column. That's all. Okay, so this is a different point. This is a different point. Okay, and this is a combined. Okay, maximum 2. We assume here this is a radial connection. Okay, this is a radial connection. So here is a 1 rotation, 1 theta, 1 theta, 1 theta. But at this point we have 2 theta. Okay, we have 2 theta. Again, at this point, please understand, the relative rotation is equal to 2 theta because not just rotation of the beam, and also there is a rotation of the column. So for this point, the total rotation is equal to 2 theta. If I didn't provide you 2 theta, some student will make a mistake. Okay, will make a mistake. Okay, so please understand, here is equal to 2 theta, and this is a combined mechanism 3. Okay, in this combined mechanism, we introduce 2 radial connections. 2 radial connections. Okay, so here is equal to 1 theta. Here is equal to 1 theta. Here is equal to 2 theta, here is equal to 2 theta again, 2 theta, 2 theta. For this point, the plus moment is equal to the plus moment for the beam, and for this point, we have to use the lesser value, And for here and here, for these two plus hinges, you just need to take the moment equal to the plus moment for the beam at the first story. And here is equal to the plus moment of the column. Here is equal to the plus moment of the column. Okay, so I hope you can understand. Okay, different plus moment, okay, should be used in the calculation of the load factor. Okay, of the load factor. So this is